and very good morning. Welcome back to Basic Exploration and Production Training. Today, we are going to learn about exploration methods in locating oil and gas reservoir. Before I continue, I would like to invite you to like and subscribe to my channel. The role of exploration is to provide the information required to exploit the best opportunities presented in the choice of areas for oil and gas drilling and extraction. There are four primary methodologies used to find hydrocarbons, which are direct method, geological method, geochemical method, and geophysical method. Direct exploration method is an early way in locating sites for oil and gas. Oil and gas explorers relied upon surface signs like natural oil seeps and outcrops, where location of faults at the surface indicated where potential structural traps may lie beneath the surface in the reservoir rocks. However, development of science and technology have made oil and gas exploration more efficient. Geological exploration method is more specialized procedure, including aerial photographs, subsurface mapping, and remote sensing. Geochemical exploration campaigns aims at locating hydrocarbon deposits through recognition of unusual concentrations of chemical components in superficial materials such as soil, stream, sediments, rocks, water, plants, and air. There are four main geophysical methods used in petroleum exploration, i.e. gravimetric, magnetic, electrical, and seismic. The first exploration method is hydrocarbon seepage. Principal occurrence of hydrocarbon seepage on an ocean surface and its detection in SAR images, synthetic aperture radar, SAR. Hydrocarbon leaking out of reservoir to the sea floor along a fault and subsequently floating up to the sea surface. Hydrocarbon seepage in oceans are direct indicators of the existence of a petroleum system under the seabed. Active microwave radar, or SAR, provides a powerful and cost-effective methods to detect such oil seepages. At sea surface, backscattering from oil much less than surrounding sea water, resulting in oil appearing dark in SAR image compared to water. A petroleum seep occurs as a result of the seal above the reservoir being breached, causing tertiary migration hydrocarbons towards the surface under the influence of associated buoyancy force. Outcrops give us important information about geological structures, rock types, and past process. Good outcrops are key to geological mapping and understanding local geological history. The outcrops are also important structural features of rocks, such as orientations of bedding planes, fault axes, foliation, depositional features of orientations, paleomagnetic orientations, which are susceptible to the geomagnetic signal during their formation. Investigation of the physical structure of the rock and its constitution and formation Physical characteristic and fossil contents of the rocks are recorded and samples are taken. Outcrops of the rock layers in the potential petroleum bearing area shows in the picture. Outcrop study. Picture shows looking at the vertical and lateral relationship of different rock type of a reservoir at outcrops, quarries, road cut, cliff, and mines. The relationship of rock layers vertically and laterally is indicative of large-scale changes in the environment. An outcrop consisting of several horizontal sedimentary rock layers represent a vertical time series of geologic events. The result of studied outcrops can be applied in geological modeling to predict reservoir properties. Outcrop study. The picture indicates presence maturity of the source rocks. The outcrop and well data able to reveal quality of total organic carbon, type of corrosion, level of maturity of source rock quality, and having an indigenous hydrocarbon generation potential. The next exploration method is aerial photograph, satellite images. Accurate satellite imagery is the most cost-effective method of oil exploration. Satellite imaging can retrieve images from the most difficult to photograph areas of the world. Geological features affecting oil and gas exploration are identified, high-resolution models, and viewed in 3D terrain visualization environments. The data can be further prepped for complex analysis such as hydrocarbon indications. The use of satellite is revolutionizing the oil and gas industry, providing more accurate and detailed information that can be used to improve exploration activities. One of the main advantages of using satellites for oil and gas exploration is that it allows companies to access data from remote locations. By using satellite imagery, companies can gain access to detailed information about the terrain, geology, and other features of given area. These can be used to identify potential drilling sites. The next exploration method is subsurface mapping. The hunt of hydrocarbon is focused at favorable or promising areas based on geological consideration. Selection and mapping of promising areas which satisfy the criteria of being sedimentary rocks of marine origin with the presence of anticline structure of Mesozoic, Cenozoic, and Paleozoic periods. They are expressed in terms of known geographic locations, stratigraphic markers, and rock composition at the depth. It is given by Geographic Information System (GIS) technology. Contour maps are widely used in this type. The purpose of subsurface mapping in the oil and gas exploration is to find traps that contain oil and gas pools. Subsurface geological maps are perhaps the most important and widely used vehicle to explore for undiscovered hydrocarbons. There are many types of geological subsurface maps. Most of these maps are prepared by contouring or drawing lines at regular intervals representing depth or thickness. There are thickness maps, structural maps and sections, geological cross-sections, facies maps, paleogeologic maps, subcrop maps, and internal property maps. The next exploration method is remote sensing to gather geological data. Remote sensing data is primarily used to examine and map the surface geology in and around its concession area, and secondly, to check terrain conditions and access routes for geologic fieldworks. There are 4 types of remote sensing imagery used when exploring structural traps. Number 1 is satellite imagery. Satellite imagery can help us examine regional structural fabrics, patterns, and contexts. Secondly, high altitude photography. Detailed mapping can be done using high resolution satellite imagery, high altitude photography. The third one is low level aerial photographs. Detailed mapping can be also done using low level aerial photograph. And lastly, side-looking radars are used to obtain higher resolution than conventional radar, improving the ability to recognize surface targets. The next one is remote sensing to gather geological data. Remote sensing can be divided into 2 methods. The first one is passive remote sensing. Gather radiation that is emitted or reflected by the object or surrounding areas. Reflected sunlight is the common source of radiation measured by passive sensors. Examples of passive remote sensors include film photography, infrared radiometers. Secondly, active remote sensing. It emits energy in order to scan objects and areas, whereupon a sensor then detects and measures the radiation that is reflected or backscattered from the target. Radar radio location system use radio wave is example of active remote sensing where the time delay between emission and return is measured, establishing the location, speed, and direction of an object. Remote sensing provides specialized image processing by color balancing and utilizing the correct band combinations to isolate the terrain features and geological information needed for correct analysis for exploration project. The next one is geochemical exploration method. Geochemical methods used in exploring for oil and gas are based on the premise that hydrocarbons migrate upward from subsurface petroleum accumulations and produce anomalous patterns near the surface. There are 2 methods. First one is soil sampling or surveys, give an indication of the chemistry of the underlying rocks. And secondly, water sampling surveys. The chemistry of the water will be influenced by the rock it flows over. The application of geochemical methods in conjunction with geological and geophysical methods are markedly improve the discovery ratio. Analysis of soil sample is to determine the amounts of hydrocarbon gases absorbed by the soil. Analysis of waters to determine the amounts of dissolved hydrocarbons, and also collected data are plotted or contoured to form maps to identify anomalies and to locate possible hydrocarbon deposits. The last method of exploration method is geophysical method. The first geophysical method is gravimetry. A gravity measurement is sensitive to cone-shaped region of the subsurface. Gravimetric prospecting is a physical technique which is able to identify anomalies in the gravity acceleration generated by contrast in density among bodies in the subsurface. Measurement of slight variations in the force of gravity at the surface of the Earth. Force of gravity at any point on the Earth's surface is influenced in magnitude and direction by distribution of rocks of different densities under the area. Older rocks tend to have stronger gravitational force than the sediments of newer basins. As depth increases, the sensitivity to individual water molecule decreases, but the region of sensitivity expands. Gravimetric prospecting is used to reconstruct of the main structural elements of sedimentary basin, such as extension, thickness, salt domes, intrusive plutons, and dislocation of fault lines. The next method of geophysical method is magnetic. Measuring variations of the intensity of the Earth's magnetic field using sensitive instruments known as magnetometers, which can be used on land, at sea, or in aircraft. Localized magnetic variations come from the varying magnetic properties of the underlying rocks. Ocean floor lavas have a stronger magnetic force than marine limestones. Magnetic surveys are useful for gathering regional framework or sedimentary basin before expensive seismic surveys are used. The magnetic method employs a magnetometer to passively measure Earth's magnetic field at points along the Earth's surface. Anomalies in magnetic data can indicate the presence of subsurface zones with high magnetic susceptibility, and those to be used for site characterization. The next method of geophysical method is electrical. Electrical prospecting methods are used in the exploration program in one of three ways. Number one, they may be used to determine the depth to resistant basement rock. They may be used to detect directly the presence of oil, or they may be used to map variations in texture associated with lithologic traps. Depends on differences in the resistance to electric currently by rocks of various types. Rarely used as surface exploration techniques, probably the most widely used near-surface geophysical techniques. In the subsurface, this method is used in various well logging tools, which help to identify formations that are drilled through. Electrical prospecting methods are being used extensively for mapping major structural features within sedimentary basins. The last method of geophysical exploration is seismic. Picture shows offshore seismic acquisition vessel where geophysicists work to acquire seismic data. Seismic exploration is the use of seismic energy to probe beneath the surface Earth as an aid in searching for deposits of oil and gas. Seismic interpretation is the science and art of inferring geology at some depth from the processed seismic record. The seismic record contains two basic elements for interpreter to study. The first is the time of arrival of any reflection from a geological surface. Second is shape of the reflection. This is used to support conclusions of lithology and current content. Of all geological exploration methods, seismic surveying is unequivocally the most important, primarily because it is capable of detecting large-scale to small-scale subsurface features. We will go through more detail on seismic survey subject in our next session because it is an important method. That's all for today. That's all for this session. Thank you very much for your attention and have a good day.